One day we were doing a powwow session with a bunch of guys, and one guy who was really very opinionated, and I tend to just shut up. I guess I learn more by listening than talking. And he said, "This is the biggest valve you can put on a small block Ford or LS." I go, "Really?" And he goes, "Yeah, that's about it." I go, "Well, you can go a lot farther than that." He goes, "Man, you got to be crazy. There's not enough bore spacing there, so forth, so on." I said, "Yeah, okay. But why should I? You know, I got to figure. He knows everything." Just like one guy told me before with big block Chevy. He's the king of big block Chevy stuff, and I asked him a simple question he couldn't answer. But anyway, I'll talk about that later on. But for now, when they tell you this is the biggest valve you can put in a small block Ford or LS, and just think about this. This video will prove otherwise. 65 thousandths. 65 thousandths.
What was that about? From V8 Fords and Chevys turbo supercharge and mostly normally aspirated. Ben dealt with many projects of many discipline as he constantly tries to learn as much as possible to whatever challenges awaits. Just like these 4-valve AMG Mercedes-Benz SLR V8 that he did research and development on cylinder heads and intakes for a 24 hours of Daytona and 12 hours of Sebring endurance racing team. It was challenging as it is vastly different from his usual projects, but nonetheless was successful, considering power and longevity. Going the distance is a priority asked of him. Beside the Mercedes SLR effort, he also did several types of Mercedes cylinder heads, notably the 3-valve turbocharged cylinder heads, which got big-time gains in power, as well as working on improving the Mercedes supercharger, looking for gains. And one of his pride and joy working with Max at Gage Motorsports on a winning cylinder head, surprising the competition. Other projects, both Max, now a good friend, pursuing other avenues of power.
Did you guys just notice what I did there? I shifted the head forward on the driver's side and back towards the firewall on the passenger side. Now, I would only recommend doing this if you are on the maximum effort small block, be it Ford small block or LS Chevy, because all the intake valves on one side, just like the LS, it's also on one side. So you're able to basically manipulate the bore centers, or basically the distance of the intake valve from the bore of the cylinder wall. It is really a trick move. I don't know, a lot of people probably claim it doesn't do anything, but you know what? I beg to differ. Just keep an open mind on what I'm about to do here. Just think about this. I'm gonna write on the whiteboard what actually happens, and take a look. Now we're looking at the dial indicator on the corner of the heads. 65 thousandths. 65 thousandths. That's how much this head moved forward.
Let us see how the heads moved around the cylinder first, in stock position, and then the shift to the sides.
Okay, just like the AFR on the preceding video, here is a 4/200 diameter head gasket. Now, when you look, still have an area here that's overhanging the combustion chamber, and a lot more on the exhaust side, quite a bit more. Now, we will see when I move this cylinder head and point it that way, and basically this head gasket is going to move farther back to your left and basically unshroud this part of the valve. Okay, and let's see how far we have as far as that is concerned, because when you look at the exhaust is a lot more unshrouded than the intake in this regard. And you know, the amazing part is Rodix, Dart, all the other ones have the same similar structure. The only thing that I have concern here is how close it is on these AFRs. All right, so let's look at the next video. Look at the scenario here as shown by the gasket. The head went this way or to your right, and look what happened to now on this intake relief here. Look how much more unshrouding you can do there to keep this valve from being shrouded. And when you look at here, is that, guess what? It just matches roughly about a 4185, 4190 bore. All right? You still get a lot more there. If you have a smaller bore like 4155, 4165, you could probably weld that a bit. Like I said, this is all for serious stuff that we're talking. And you can get that much, much closer. When you look at here, still far from being shrouded. Big time far. Now, this one here, look how much opening it has. So when the valve opens up this way, you can lay that down. And guess what you have? A lot more unshrouded area. So what are the possibilities? Also, may I remind you, I think this is a 210 valve, intake valve. If you go up to a 220, this moved, okay? This moved backwards 0.65. If you made this valve bigger by 10 thousandths, from a 210 to a 220, you still have a lot more room here that is unshrouded. And remember, what is the diameter? The throat diameter of a 210 versus a 220, that's where you get your flow. Because you can always go bigger valve. Okay? If you go bigger valve, but without correcting your throat diameter, what did you get? Hardly anything. Just a heavier valve. Now, what I don't like here with the AFR, it's too close already. So you can't really put a bigger valve, per se. Okay? So, what I would have done is that I would have opted for a 156 exhaust valve or 158 and pick up the slack here, the difference that you took off, okay, and add that to the intake and get a little bit more flow. Or like the other heads, the intake valve is a lot spread around this area. The other brands, check whatever you have, and you can actually go from a 210 perhaps to a 214, 216. That's a big possibility. Or if there's really no budget issue at hand, you can offset your guide here, okay, and push it there and move your intake valve this way, and you pick up flow. Now, when you look at the throat diameter of a 210 versus a 214, 216, or maybe a 220, if you really want to force the issue, you got a lot more here. You can add easily 20 thousandths or 15 thousandths to 220, 210 to, you know, oh shit, I think I can fit a 220 here. Oh yeah, 220. And probably force a 222. And then the corresponding diameter of the throat. Who said you're not going to gain anything from here? But I can see this one here, even staying with the 202 or 210 valve and relieving this area here and open it up, okay? Especially with a supercharger or a turbocharger, you're giving it that much room right around there. And you're going to pick up flow. So when I said I moved the head and it didn't gain anything, if that's what somebody's opinion would be, I could see that. But the fact of the matter is, I would like, when you're at this level, when you move the head one way, this way you add intake valve diameter. Then you got a double whammy. You can't do that with any other small block Chevy, okay, or even the Mopar. The strictly Ford and LS.
Side shifting the Chevrolet LS heads.
Here's an LS that I move the head this way, Opposite of the Ford. Excuse me, I'm using a Ford head gasket here. It's basically the same, the bore spacing. But look how much more area I have opened up. Okay. And this particular cylinder head here is cathedral port. So you can really make up a sleeper. And look what's good with this compared to the AFR. Ford AFR. You got a lot more space. If you really want to be slick about it, you put a whole new seat here. And you can add a lot more intake valve. Here, it's so obvious. You can really pick up the diameter of the exhaust valve from what comes in stock with this one. And then you relieve it right here. So when the valve opens up, we can see how much shrouded that is. When the valve comes up straight up, you can lay this down, lay that down, and with a bigger diameter valve, and just tell somebody, oh, I just got a cathedral port. And they'll probably get suckered in. Okay? And the good part about that, they will not see you coming with this kind of combination. And if you could put a big valve in there, I'm not going to tell you guys how much, but significantly bigger, because I can see it right here. And do some modification of cathedral port or even the standard rectangular port LS. And do this same thing. Guess what? I don't care how much modification you have. If LLs being similar displacement, or they could be slightly bigger, but if your heads breathe better, by far, you're going to beat them. Is it obvious? Because when this valve opens up right here, it is so shrouded, big time. Now you have that much more area open right here. So when this valve opens up about 550, 500 lift, it is uncovered. And look how much more you have left on the exhaust. Okay? So don't worry with the LS when you move it one way or whichever. Okay? You're still got quite a bit. Especially on the exhaust side, unlike the Ford. You get close there already. But if this was a big combustion chamber, it might make a little bit of an issue. But otherwise, this LS is pretty much a give and take. And for this combination, even for the street, not really all-out racing, it will give you dividends. Just by that opening right there. That's a big jump in power. Okay, because I know the LS engines come with 4125. If you have an aftermarket block, you can go 4155, 4185 like here, 4200. That was gonna be a big jump in horsepower.
A close look at the details of what this is all about.
Here's a 4-inch diameter bore, just for example, for the sake of just explaining. With a 4-inch bore, let's just say our intake valve is that far away from the cylinder wall at 100 thousandths. Now, with a 4130 bore, okay, and you cut 4130 divided by 2, it's 0.65. Now, our original 100 thousandths now becomes 0.165 additional. Okay, so we have 165 or 65 thousandths more breathing space or shroud opening. Okay, now since I moved the head to the left an additional 0.065, what we actually have now is 0.230, because 165 and an additional 65 thousandths, now it's 0.30, almost a quarter of an inch, signified by that red line. Almost a quarter inch additional clearance. But when you look at the 4130 existing here with the valve move, 4130 and a 65 move to the left also signifies 130 thousandths bore from what the intake valve sees from here on to the wall. That's basically a 4260 bore. Impressive, isn't it? On a 4130, you fold the intake valve into thinking. It doesn't see this side really. It only sees this side. That sensitive part of the cylinder wall. That's what it sees. And it sees a 4260 bore. Now let's look at a 4185 scenario. Taking into account the 100 thousandths. Now with a 4185 bore, it's got 92 thousandths additional clearance, given the existing 100 thousandths. And then the 92 now becomes 192 thousandths clearance, plus a move to the left of 065. It gives a clearance, okay, a shroud clearance of 0.257. And if you look at a 257 clearance, additional clearance, compared to this one here at 230, this is quite significant. Guess what that does? 4185 bore existing, and then you move it 65. Now it folds the valve into thinking it's an additional 130 of bore diameter. So the actual bore diameter, sorry for the chicken scratch early in the morning, there's all I could do real quick and put together. It's actually a 4310 bore size. That's big block territory with a small block cylinder. Is that supposed to work? You can actually, if you ended up with a 210 valve, you can increase your diameter easily 25 thousandths, because you have 257 additional, and you're still far from the shroud point of the cylinder. What did I accomplish by doing this? Well, when you flow test a cylinder head, it's very important that you use the correct diameter bore that cylinder head is meant for. Basically, if you have an LS engine with a 3.9 bore, or a small block Ford, or a legacy small block Chevy with a 4-inch bore, then you gotta run a 4-inch bore when you flow test the cylinder head. Because if you use a bigger bore diameter like a 4125 or a 4155 or so forth, so on, bigger than that, it will tend to skew your flow reading. So when somebody tells you this movement or this trick doesn't work, well, what happened to the flow bench when you use a bigger diameter bore size when you flow any cylinder head? It'll cheat, because guess what? It picked up flow. And I still didn't touch bases on what else is to be gained further by doing this move. Remember, you gotta use the correct bore diameter to honestly flow test your head. But there are instances in there when you flow test a head and you use a bigger diameter, it actually loses flow. It does happen. I've seen that happen. Sometimes it's the angle coming from the seat, okay? From the seat to the departure angle from the seat when the valve opens up. This angle, if it pulls away too hard, you start creating turbulence. You gotta leave some kind of pressure in there so that when the valve opens up, just like when you're turning a curve, okay? If you have a flat curve, a left turn or a right turn, the heavy car will slide off and hit the guardrail. But if you tilted it, gave it some angle to bank on, just like the flow needs something to bank on, something to hug, to keep them all together. Because if you have a big breakaway on the seat, the heavy fuel particles will spin out. The air will probably navigate it, but the heavy fuel particles will slam through the outside, if even that. So now you have an issue of fuel and air separation. So bear in mind, this can happen. But everything being said, or being normal as it is, all right, without any of those crazy things that some people do to get more flow numbers out of the flow bench, if you're gradually blend in the bigger diameter to the combustion chamber, make a real nice departure angle there from the seat. All right, no more than 15 degrees, or if you can keep it within 5, 6, maybe no more than 8 degrees, why not? It would probably help it out. All right, so if you get a 45 and you bank off to a 50 or maybe a 53, you'll probably be good. All right, but if you have it all the way to, just like some people just put it there and start carving the combustion chamber to match the bore, but now it laid it down so much, well, guess what? You're gonna have this issue, and sometimes you will lose flow in that regards, because now you made it turbulent. And if it's not turbulent, then you could possibly have some fuel and air separation as well. So this said, I'm just stressing, when that intake valve pulls farther away from the cylinder wall, the better you're gonna be. Okay?
How did Ben move the head sideways? It is not as hard as you think.
First, what you got to do is mark your hole, your dowel. That one there, and on the other side as well. And then you got to use a dial indicator and set it up to 60 thousandths. Whoop. There you go. 60 thousandths. Okay? Lock it down. And then you do this. Now you've scribed it. You can see the scribe mark right there. Very, very obvious. Let me do that again. Make a deeper indentation. There you go. All right, now you start grinding that. The scribe marks you saw, on the head fits on this thing here. And when you move the hole, bolt holes or the dowel holes off one side, that's how you space the head, okay, to the other side, or move it 60 thousandths or 65 thousandths. This is how I do it, and this is your reference.
After offset drilling, confirm how much movement you have before doing the head bolts. Proceeding to the head bolts or studs. No need to drill the offset holes on A302 because they use 7/16 head bolts. On A351 we will show next how it is done, and it is not complicated.
Also, on a 302 base block, the head bolts are 7/16. Okay, so you don't need to machine the heads or the bolt heads to move the casting to one side. Whereas on a 351, they are 1/2 inch head bolts. Okay, and this is how you need to re-drill the head bolts to facilitate the move to one side. After you scribe the line, then you use a high-speed grinder and come through here, and be patient, no use to rush. That type or this type, and go through there on a drill press, or usually I stand up the head and I grind it till I get the right clearance, and I use a straight edge to make sure I'm flat all the way from one end to the next. It's not overly critical on a the block, because the head bolts usually is really loosely in this bore, so you don't need to really cut big time, and then you can start spacing. Do that on all 10 head bolts and you're going to be fine.
This is how the chambers looks like before we shifted the heads.
There you go, you can see the scribe marks right there as well. Can't really, but let's just use the cylinder. You can see the scribe marks there.
After the head dowels and head bolt studs has been grounded, this is how it looks after it shifted 60 thousandths away from the cylinder walls.
There's a lot more opening. You can see right there. You can see very, very clear how much more that went away from the wall. If this was a 125 block, 125 bore, and I'll do that next with a block with the 125 bore, and we'll show what this one would just do. Absolutely phenomenal. Anyway, I hope this was a very informative video. Like I said, I'd like to bring different aspects of hot rodding or engine building to all of you, or to many of you, and not like the usual things that you see, float test, dyno this. I like to do more racetrack and applications that are something that you can think about. And in the meantime, if there are probably many out there that will not believe in this concept of moving the head to one side, but if you really look at the essence of and gains of taking the intake valve away from the cylinder wall, if somebody disagrees with that, I don't know what to tell you, because shrouding is a big part of 2-valve technology. Even with 4-valve engines, you have 2 valves and 2 cylinder wall per side. That is part of the restriction or the shrouding. So if this is not believable, well, I don't know what is, okay? Because shrouding is a very big part of the restrictions in a racing engine, intake and exhaust. And the benefits here, the exhaust is under pressure. Most modern cylinder heads, the exhaust valve is shrouded more than ever, and a smaller diameter more than ever. The intake valve keeps getting bigger and bigger, and the concept of moving away from the cylinder wall has its benefits. And when you see the Yates engines and the SP2, they're rotated this way, so that the valve, the intake valve is a little bit towards the center of the bore, which has its benefits. And just think about this. The Boss 302. The Boss 302 in 1969 had a 224 intake valve. That's a small block on a 4-inch bore. It's got a big valve, has a big valve, bigger than a big block Chevy. And in 1970, they switched the Boss 302 to a 19 valve. And same thing with the 351 Cleveland's 219. Therefore, I see big dividends of moving the cylinder heads, even on the Boss 302, as tiny as it is with such a big valve. Anyway, good night. Hope you enjoyed this. Please make a comment, see what direction you want me to keep going, and thank you very much. Please like, share, and subscribe. Thank you.